Hello and welcome back to the course of
Fundamental of Electronics and Electrical Engineering.
In this video lecture, I am going to discuss few terms related to the alternating current or voltage or alternating quantity. In the previous lecture, I have discussed generation of alternating voltage and derived the equation of alternating current. In this video lecture, I am going to discuss few terms which is related to the alternating current or voltage and which will be used in the upcoming video lecture frequently. So it is necessary to understand all the terms which is related to the alternating quantity. So let us discuss which are the terms definition that I am going to discuss in this video lecture. So starting with the first one, that is definition of waveform, instantaneous value and amplitude. The next one is a definition of cycle and time period. The next one is a definition of frequency and angular frequency. And the final one is a phase and phase difference and one example based on phase difference, how to draw the waveform with different phase difference. So these are the different definition that I am going to discuss and which is very important for this particular chapter. So starting with the first definition, that is waveform. The shape of curve obtained by plotting instantaneous value on y-axis and current time or angle on the x-axis is known as waveform. So here you can see these are the two waveform which are the waveform of voltage versus time, and both are alternating waveform, both are changing periodically with time. On y-axis time may be there, angle may be there, different things can be there on x-axis. The next one is a definition of instantaneous value. So the equation which we have derived in the previous video lecture is V is equal to Vm sin omega t. So it is a graph of voltage versus time. You can see it is a graph of voltage versus time. The value of alternating quantity at any instant is nothing but the instantaneous value. So here you can say at instant pi by 2 the value is Vm. At instant t1 the value is V1. So the V1 at instant t1 is nothing but the instantaneous value of the alternating quantity. Alternating quantity consists of infinite number of values in one cycle. The next one is nothing but the cycle. The complete set of positive and negative value of alternating quantity is known as cycle. So here you can see it is a graph of voltage versus time, or you can also x-axis you can also take omega t because it is a graph of Vm sin omega t. So one cycle means what? One cycle consists of two half cycle, one positive and negative. So it is a set of positive value and negative value of alternating quantity. The cycle can be spread over 0 to 360 degree or 2 pi, 0 to 2 pi. The next one is time period. The definition of time period is what? Time taken by alternating quantity to complete one cycle is nothing but the time period, which is measured in terms of second, which is represented by capital T. Here you can see again the graph of voltage versus time. So one time period duration you can see. Now suppose an alternating quantity has time period of 5 seconds. What does it mean? It means that it completes one cycle in 5 seconds. Time period is not only measured between 0 to 0 value, it can be measured between maxima to maxima because alternating quantity is repeated. So between two maximum value we can also get the time period, between two minimum value we can also get the time period. The next one is amplitude or peak value. The maximum value of alternating quantity is known as peak value or amplitude. So here you can see one graph, again the graph is of V is equal to Vm sin omega t alternating quantity. So here maximum value which we are getting you can see is at pi by 2. So Vm is nothing but the maximum value. The maximum value of voltage is represented by Vm or Em, or it maximum value of the current is represented by Ia. So here you can see in one cycle alternating quantity consists of two maximum value, one positive maximum value and other one is negative maximum value. So amplitude, peak value or maximum value are the same terms. The next one is frequency. Frequency is related to the time period. Both have inverse relationship. The number of cycle completed by alternating quantity in 1 second per second is known as frequency. Unit of frequency is what? Hertz. So here you can see again one graph is there which is voltage versus time graph or omega t graph. So number of cycle completed by alternating quantity is frequency. So suppose if frequency of a signal is 20 hertz, what does it mean? It means that that's quantity, in that quantity 20 cycles are completed in 1 second. In India, the line signal voltage which we are getting at our home offices, that alternating quantity, that alternating voltage has frequency of 50 hertz. That means what? It means in 1 second 50 cycles are completed. The next one is different form of EMF equation. How we can represent the EMF equation by different form? So here you can see it can be represented by V is equal to Vm sin omega t, E is equal to Em sin omega t, or in place instead of omega t we can also write the theta. So V is equal to Vm sin theta, where omega can be also represented by 2 pi f, that is angular frequency. So we can write V is equal to Vm sin 2 pi f t, where f is what? 1 over t. So we can write V is equal to Vm sin 2 pi by t into t. So in the given equation V is equal to Vm sin omega t, the amplitude is what? Amplitude is a coefficient of sine of angle. Suppose this is the waveform of V is equal to Vm sin omega t. Now if one example is given to you, in this example you have been asked to find out the amplitude and frequency. So the equation of alternating voltage is V is equal to 50 sin 314 t. Now as we already discussed that coefficient of sine of angle is nothing but this amplitude. So here we can see Vm or amplitude is 50 volt. In this example you have been asked two things to determine voltage and frequency. So amplitude is 50 volt. Now comparing this equation with general equation of alternating voltage, that is V is equal to Vm sin omega t. So we are getting omega is equal to 314 and omega is the angular frequency which is measured in terms of radian per second. So 314 is equal to 2 pi f. So f is equal to 2 pi by 314. So we are getting frequency is equal to 50 hertz. So this is the way to find out voltage and frequency of the given expression of alternating voltage or current. The next one is the angular frequency which we have already discussed, which is measured in terms of radian per second. It is represented by small omega. Small omega is equal to 2 pi f, where f is equal to 1 over t. So omega can be also represented by 2 pi by t, and it is measured in terms of radian per second. The next one is what? Phase. What is the simple definition of phase? Position with respect to some reference point. Here one signal is there which is starting at 0 origin. So this is the reference signal. Now position with respect to this is nothing but the phase. Another definition of phase is what? It is defined as fraction of time period of alternating quantity which has elapsed since the current has passed through 0 position of reference. Now suppose in this particular voltage waveform, if you have been asked to find out phase at angle A, so phase at angle A is nothing but the t by 4. Similarly, at any point, at any instant t, the phase is given by omega t, where omega is angular frequency. The next one is a phase difference. The phase difference between two alternating quantity having same frequency is the difference of phases at maximum or zero or minimum value of two alternating quantities. There are two waveforms. It is a voltage versus time waveform. Now one signal, voltage waveform V is equal to Vm sin omega t, is starting at origin. So phase of that signal is 0. Another signal is a current signal waveform, which is starting after some time with respect to voltage waveform. Suppose it is starting at some angle phi. So that signal is mathematically represented by I is equal to Im sin omega t minus phi. That quantity is represented by I is equal to Im sin omega t minus phi. How we have calculated the phase? So to calculate the phase, we have to compare to maximum value or to minimum value. So minimum value of V is equal to Vm sin omega t is at 0, and for current it is at some angle phi. So phase difference between two is phi. Now why it is a negative sign? Why it is minus phi? Because it is lagging, current is lagging behind the voltage. Current attains its minimum value after the voltage. Similarly, we can also use maximum value to define the phase difference, to calculate the phase difference. Now there are two types of quantity, in phase quantity and out of phase quantity. Now what is the definition of in phase quantity? Two alternating quantity are said to be in phase when they attain maximum value or zero value at the same time. So here in these two waveform, you can see voltage and current both attains minimum value, zero value and maximum value at the same time. So both are said to be in phase. And in phase means what? Phase difference between these two quantity, voltage and current, is zero. Condition to determine the phase difference between two alternating quantities is that both quantities should have same frequency. Now next one is a out of phase. Two alternating quantity are said to be out of phase when one alternating quantity attains maximum value and other attains negative value at the same instant. So these two quantity you can see here, both are not attaining maximum or minimum value at the same time, but here when one waveform attains maximum value, other is attaining minimum value. So we can say there is a phase difference of 180 degree between these two quantities. So these two quantities are known as out of phase quantity. In the upper case, you can see both quantity attains same maximum value at the same instant. So both are said to be in phase quantity. The next one is one example I have taken. So how to draw the waveform from the given alternating quantities expression, or if waveform is given, how to find out the equation of alternating quantity. So for example, I have taken here three voltage, alternating voltage V1, V2 and V3. Now this is the first waveform V1. So you can see it is spread over 0 to 360 degree, and I have taken the instant at 30 degree, 30, 60, 90 and so on up to 360 degree. Now this voltage is starting at origin. So we can see it can be represented mathematically, it can be represented by Vm sin omega t. The next waveform is of voltage V2. So here you can see V2 is starting at 30 degree. So, and it attains its maximum value at 120 degree. V1 attains its maximum value at 90 degree. So there is a phase shift of 30 degree between V1 and V2. Clearly it can be shown from the graph. So V2 is represented by Vm sin omega t minus 30 degree. Vm sin omega t is a reference waveform, is a reference signal. As compared to that, V2 is lagging by 30 degree. So it can be represented by V2 is equal to Vm sin omega t minus 30 degree. For determination of phase difference, you have to either take minimum value or maximum value, but after the origin, after 0 point you have to calculate. The next voltage waveform is a waveform of V3, which attains its maximum value at, you can see its maximum value at 60 degree and minimum value at minus 30 degree. So what is the phase difference between V1 and V3? V3 attains its maximum value at 60 degree, you can see here, and V1 attains its maximum value at 90 degree. So there is a phase shift of 30 degree between V1 and V3. But as V3 attains maximum value earlier as compared to V1, so it is said to be leading quantity and V1 is said to be lagging quantity. So V3 is represented by Vm sin omega t plus 30 because it is a leading quantity. That's why plus sign is there. Now which are the conclusion from these three waveforms? So first, V1 leads V2 by 30 degree. Second, V3 leads V1 by 30 degree, or we can say V1 lags V3 by 30 degree. V2 lags V1 by 30 degree and it lags V3 by 60 degree. So this is how you can draw the waveform from the mathematical expression given of alternating quantity. In this lecture I have discussed few definitions which are related to the alternating quantity and which will be used in the upcoming video lecture. Hope you have enjoyed the video. See you soon in the next video. Thank you for watching.